In today's lesson, we'll learn about friction. The essential questions are, what is the friction force, and how do static and kinetic friction differ from each other? Now, if you were to push your book across a desk, you'll notice that when you stop pushing, the book will come to a rest. What's happening here is that there's friction force. It's acting against the direction of motion. So far we have not considered friction in solving our problems, but friction is everywhere. There's two main types of friction. When you push something and you get it moving, the object will experience a type of friction that acts on moving objects. This is known as kinetic friction. This is exerted when one surface acts on another. It's two surfaces rubbing against each other. So take a look at figure 7. Here is someone pushing on a couch. If you push with a small amount of force, the couch doesn't move. That means that the force of friction is opposing the motion. It's equal to the amount of force that you've applied. Notice that the force of static friction will vary. It depends on how much force you're applying. If you apply a tiny amount of force, there'll be a tiny amount of friction force. If you push harder, the friction force will become harder. Eventually, you push hard enough that you overcome the force of static friction, and the couch begins to move. At that point, the opposing force is kinetic friction. So let's see, what determines the force of friction? The materials the surface is made of definitely play a role. If you have two really sticky surfaces, like shoes and a floor, that will have a very, very high frictional force. On the other hand, if you have something that's very slippery, if you had socks on a polished wood floor, that would be a very low friction force. So it appears that the first thing is the type of object, the type of materials. What are they that determine the friction force? The other thing is the amount of force that's between the two materials. In this case, it's not exactly the force of gravity. What it is it's the normal force. Look at figure 8. Here's an experiment where we're pulling a block across a surface. If you were to stack additional blocks on top of this first one and repeat the experiment, you'd see that it would require more force to have the block move. Take a look at figure 9. Here we see a plot of the kinetic friction, the force of friction on an object versus the normal force. Notice that the greater the normal force, the greater the force of friction. Here we're looking at three different situations where we have sandpaper, a rough table, and a very highly polished table. In each of these cases, the slope of the line is different. For a very rough surface, you're going to have a lot of friction, a great increase in friction as the normal force goes up. For a very polished table, the force of friction will be much less. The slope is what is known as the coefficient of kinetic friction. You can see here in mathematical form, the force of kinetic friction is equal to this coefficient of friction represented by the symbol mu sub k times the normal force. The other situation is static friction. The force of static friction is less than or equal to the coefficient of static friction times the normal force. Notice that inequality. It is less than or equal to the coefficient of friction. If you push with a very small amount of force, the static friction force will be very small. When you push harder, the force will increase. So table 2 is something you will need to complete the lunch homework. Notice that for different materials, the coefficient of frictions are different. And also note that the coefficient of static friction is different from the coefficient of kinetic friction in many cases. Once you break something free and get it moving, the coefficient of friction often becomes less. Finally, let us consider a sample problem. Here we're going to draw a free body diagram the way that we have done previously, but now we're going to look at forces in two directions. So if you push a 25 kilogram wooden box across a wooden floor at a constant speed, we give you the coefficient of kinetic friction, how large a force do you need to make the box move? Note the free body diagram, we have a normal force and force of gravity balancing each other out. In this case, since we're going to add a constant speed, the acceleration is 0, so the net force in the horizontal direction is also 0. That tells us that our force of friction is going to be equal to the applied force. So we have several knowns. We have the mass is 25 kilograms, our acceleration is 0. The velocity turns out to not matter in this case, and the coefficient of kinetic friction is 0.2. So let's continue on. Let's solve for the unknown. First thing we know, in this case, the normal force is equal to the negative of the force of gravity. And we're going to find the force of gravity. So the force of gravity is going to be the mass of the object times the acceleration due to gravity. That gives us a force of 245 newtons. Now the pushing force is in the x direction. We know we have constant velocity, so the box is not accelerating. That tells us that the applied force is going to be equal to the force of friction. In this case, since we have the normal force and we have the coefficient of friction, the force that is applied will be equal to the force of friction. In this case, just take the coefficient times the normal force, and we get 49 newtons. The force of friction is 49 newtons, so the applied force has to be 49 newtons. So with this information, you should be able to finish up the Launch Homework 5.2. Have at it.